HVAC 360 is brought to you today by Snuggle Suits by Comfort 100. Tired of comfort complaints? HVAC systems just getting too darn expensive to operate and maintain? Look no further than the Snuggle Suit. Using mental synaptic control, this diving suit-like material heats and cools your body right into the Goldilocks zone automatically. Just think comfort and it's yours. These suits are made by Comfort 100, whose company goal is nothing less than 100% occupant comfort in the built environment. Don't wait! With the holidays just around the corner, nothing makes a better bonus than a Snuggle Suit. Be that epic boss. Order now. Hey, what's up? Welcome back. This is episode number 106. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. How do we do that? Well, we do that by sharing lessons learned in the field and talking to industry experts. But we really don't stop there. I encourage you to double down on your weekly dose of HVAC knowledge by hopping on over to HVAC360.com and join my growing community of people just like you. We're going to be doing some exciting things over the next couple of weeks, so I don't want you to miss out on your opportunity to get in on those deals and special opportunities. So hop on over now, pause the recording, do it when you get into the office, but just get on there and get in the list. All right, so what's up for this week? This week is I'm going to finally revisit my train wreck of a podcast about thermostat operation. When my goal originally was to create something as much as I can with audio, make it something visual that you could actually kind of see. But I did a couple of things that didn't work out so well. First, the visualization that I tried to put into motion was a little bit clunky, and it also did kind of brush aside the explaining T-stats in general, thermostats in general. It was focused a little bit too narrowly on specific types of thermostats. And I never, I always kind of assume a certain basic knowledge that you have as a listener. But I really wanted to kind of take a step back, kind of give it a broad brush, and revisit this thermostat operation and kind of go over again kind of my frustration with thermostats, and we'll get into that later. But first, I want to give a big shout out to one of the listeners who had left me a review. I thank you on iTunes in Canada. This is Kamloops Bob from Canada. Thank you so much for that kind review that you left for me. So let's get into it. First off, this is not an extensive lesson, but it's really just, you can think of it as the beginning of a conversation. Why in general are we talking about thermostats? Thermostats ultimately is, they're the most important piece of arguably a most important piece of an HVAC system. It is where you determine comfort levels. Comfort is king when you talk about HVAC. I mean, HVAC, it's all about comfort. There are some special things, and we're not necessarily talking about the fringe applications with controlling on processes, controlling on, for different sort of low temp applications for food storage and refrigeration. We're just talking about HVAC, general comfort in your house, comfort in your office, comfort in your building. So that's what we're kind of going to try to focus on right now. Why is it so important? Because I think a lot of people miss the it seems so like one of those things that seems so simple. They kind of take it for granted, but obviously there are a couple examples, and I don't know if I've mentioned these before, but from a school. If you had a school building and you weren't able to maintain temperature and kind of got away from you, say on a unseasonably warm day, those kids may be taking a test, and that test could impact the rest of their lives. So whether or not they did well on that test is all based on thermal comfort. I mean, that's life changing. I mean, what's more important than that? When you talk about businesses, you could talk about making mistakes if you're not, if your focus isn't on your job, or just, standing around complaining about being too hot or too cold or not being able to focus. I think, we're coming up in this holiday season. I was thinking about the Christmas Carol. If Scrooge would have thought about it, he probably wouldn't have, he probably would have thrown on a couple more lumps of coal on the fire, knowing that Bob Cratchit would be able to focus better on his work, make fewer mistakes, and work longer instead of just shivering and not being able to do his work properly. So that's kind of the importance of why we're talking about thermostats. I mean, I think that they are kind of the linchpin, our connection between our systems, our hidden systems that make buildings comfortable and spaces that you want to be in, and the connection to the people who are actually in those spaces. So that's kind of the link there. So, getting into some of the basics of the thermostats, we're talking about, I guess, some of the things that we talk about when we talk about thermostats, different types of thermostats. There's going to be a set range. For comfort, it's pretty easy, but when you deal with different applications, is the thermostat that you're selecting really specific for that application? Is it going to measure the right things? And, a lot of times we deal with thermostats with air, but there are also sensing things. If you're sensing water in a pipe, is it going to be the right temperature? If you have an example of this would be if the thermometer, for example, a thermometer is a little bit easier to kind of identify. But if you had a thermometer that was in a pipe that was measuring hot water, and your thermometer was from 0 to 100 degrees Fahrenheit, that's not going to be a great representation of the hot water, which needs to be more of a 50 to 250 kind of range as far as the Fahrenheit scale goes. So you want to make sure that your application matches what you're doing. A lot of times accuracy, we don't necessarily, that's not a huge deal in comfort HVAC, but it is something that you need to take into account for, and also response time. Is it something that's going to be changing slowly, or is it going to be, something that's going to be reacting fast? Generally speaking, when you're dealing with comfort, you're dealing with something that's just going to be changing slowly. It's not, it's the accuracy has to be relatively good, but it doesn't have to be, totally precise. And the range, it just has to be in a good occupiable range, around 70 degrees Fahrenheit, plus or minus, say 30 degrees. I think that would be something that would be reasonable. So those are some of the things some of the basic kind of things that you want to talk about and think about when you're talking about it. But ultimately, you're going to boil it down to 3 different types of controls when you're talking about thermostats. And this is talking about the control and how they're made. So the first one is going to be what they call a relative dimension. And what that means is there is going to be two different materials that have different coefficients of expansion. Which basically means if it's exposed to one temperature, you're going to have one kind of deflecting. I guess you can imagine 2 metals. They're sandwiched together. They're different materials, so when they're exposed to a temperature, they deflect or they actually move because of the different coefficient, expansion coefficients. So that's kind of your basic run-of-the-mill. This is when you take a look at the thermostat and you see a coil. It might be just kind of a straight line. It might be U-shaped, but it has some sort of, just by the fact that the material, there are 2 materials that are going to be different, you're going to have some sort of movement that's going to actuate a response. It's going to trigger a response at a certain point. When the temperature gets to a certain point, it's going to trigger a response. And there are a couple different types of thermostats that do that. Another one that you're going to run into is the state of vapor or liquid. These you'll find a lot of in what they refer to as a sealed bellows element, where it's going to, based on the pressure, it's going to increase or decrease the they expand or contract the bellows, and the bellows element is, when it reaches a certain point, is again going to make that contact, it's going to make that connection. You might have a remote bulb, where it's kind of the same same situation, but it's remotely located from where your actual control device is. So it can have a remote bulb, and it's going to be sensing based on, the bulb pressure. And again, these are all kind of, nothing to do with electronics here. It's once they actuate, that's the electronic control portion of it. So these are all just kind of, metal coefficients, the way they bend, the way they expand, the gas and liquid, the way they expand in a, capillary tube, things like that kind of change a dimension, and have that actuation. And the third one is electrical properties. So this is where we get most of what you see in a commercial HVAC. Probably 90% of the thermostats out there are going to be of that electrical property type. And these are kind of, they fall into two camps. There's the thermistor and the RTD, which is the resistance temperature device. Probably the majority of what you're going to see out there is the thermistor, but they both operate on the same principle, is that at a different temperature, the material that they use, the sensing element that they use, is going to change in its electrical properties. It's going to change its resistance, and that change in resistance is going to be read by another kind of smarter device, whether it's the VAV box or whatever. So, whereas the other two kind of, the relative dimension and the vapor liquid change of state, those are going to be something that you're going to have that are going to, when it reaches a certain point, it's going to, it's going to click, it's going to snap, it's going to actuate, it's going to make that connection, and it's going to, heat or cool. But the electrical, that electrical property, that thermistor, is just something that changes its value based on the temperature. And that resistance, that number, that actual analog number, is going to be read by something else, and that is going to be used to make a decision. So I guess those are the three types. Hopefully I did that justice. The most reason why you use the thermistor, just to point out, is that it's one thing that's low cost. It has a good scale versus temperature, which means basically, a slight change in temperature means a very detectable or discernible change in electrical resistance, and they have some long-term stability with that device. That's why they use those thermistors. So in general, I guess these two things fall into kind of two different categories. I like to think of them. So the basic types of controls, they're either used in a line voltage application, where you're going to have it, either like a unit heater mounted or a remote mounted kind of device, where, and I guess where that's important, and where I kind of, during, when I was designing, the importance there is that, okay, you're going to need to let the electrician know that not only do they have to wire up the device, wire up the cabinet unit heater, the unit heater, whatever it is, they're also going to have to wire up the thermometer, the thermostat, because that in and of itself is a 120 volt line voltage device. So you just can't have any low voltage electrician put that on there. It has to be by a certified electrician. So you're going to have to make sure that, if it's not attached to the device, they know where you want to put it. And again, this is kind of a coordination issue. The other type is just having control voltage. So this is 24 volts or less. You're dealing with signals such as like 4 to 20 milliamps, or you're dealing with 0 to 10 volts. Those are some of the common control voltages out there that you're going to see. So they fall into those two different varieties, and you can see where the control voltage, this 24 volt or less, is going to be more of the thermistor, going to be the RTD, those type of elements, because they're actually sensing those small changes in the electrical resistance. That's what gives it its control signal. Whereas the line voltage, it's really kind of more of a self-contained kind of thing that you're gonna be using. All right, so now that you have those kind of different control types and, generally speaking, kind of electrical voltage varieties, now we kind of get into the thermostats themselves. So what do they do? So I kind of group these into two different categories. You had the intelligent or self-contained stats. This is one where you see more of a user-selected mode. These are more standalone, again, self-contained, standalone, those type of things. And you get into examples of these from the simple, which is like a unit heater. So typically you might have a bimetallic element that is going to be, based on the temperature. It's going to reach a certain point. You're going to have a set point, and it's going to reach that set point, and it's going to turn on and activate and make sure that thing heats up. I think it's important to notice that you can have the action go both ways, and what I mean by that is if a temperature is dropping and you want things to heat up. So if the temperature is dropping, it's going from 72 degrees, 70 degrees, 60 degrees Fahrenheit, and you want it to kick on at 60 degrees, then it actuates. And so at 60 degrees, it'll turn on your device, and it'll end up starting to heat up. Now it goes the other way too, but when you're thinking about cooling mode. Say, for instance, you had it, so that type of thermostat used for heating, but when you had the opposite thing happen, when you're talking about like exhaust fans in a mechanical room, say, for instance, so you want to turn on the exhaust fan whenever it gets to, say, 80 degrees, whatever the set point would be. So when the temperature rises and it keeps rising, then it's going to click on when it reaches that 80 degree set point. And it's going to take it down to a certain, whatever it's going to drop the temperature, and it's going to turn off whenever it gets below that set point. So it's going to break it. You're going to make the connection, you're going to break the connection, but when it's going down, when it's shrinking, decreasing, it's going to break that connection. The fan's going to shut off. So again, it depends on how you're either making the connection or breaking the connection, which way you're actually moving. So there's a difference. If you had something that, for example, was supposed to be an exhaust fan and it was mounted to a unit heater, well, your unit heater would just keep, would just keep heating up. It just wouldn't work right. And I found that happen a couple of times. It's not super common, but I've had that happen a couple of times. You got to understand, okay, when it reaches a certain temperature, do you want it to turn off or turn on or shut off? So you got to keep those. And again, these are typically going to be those line voltage stats. They're going to be that relative dimension. It's going to be the vapor or liquid kind of sealed bellows element type, remote bulb type of actuation. So that's that. Now, on the other hand, you have sort of some intelligence. I guess most people have a programmable thermostat of some variety in their home. And that you can actually select. That's going to be a low voltage. So you have your transformer, a little transformer that's located down in the unit, the furnace that you have, your air handling unit. And it's going to send up the wiring. You're going to have low voltage wiring going to the back of your thermostat, and you're going to select whether you want a heating mode, whether you want a cooling mode, or whether you want auto, which it can select either or, but you're going to have basically a set point that you're going to set to it, and when it's above, depending on heating and cooling, it'll actuate that accordingly. So I guess that's the third type of kind of user, intelligent, I guess, what I'm referring to as an intelligent, self-contained, user-selected mode. Now, when you get into the commercial world, for some of the majority of the thermostats that are on there, again, I call them thermostats, and I think that might be a little bit of a misnomer. I just keep calling them that. They're mounted on a wall. They might just be thermistors, but I'm not going to split hairs and not call them thermostats. But thermostats on the wall, because they're just a sensor. That's all they are. And what you have on the wall, and there's a couple different varieties, but the thermistor on the wall is just getting data. It's detecting the temperature, changing that electrical resistance, and sending that information somewhere back to the building automation control, whether it be the controller on the VAV box or wherever that device is. But it's not necessarily resident in that device on the wall. It's the logic is contained somewhere else. It's just getting its set points and maybe a couple other points of data on that thermostat on the wall, and it's doing something somewhere else. Now the thing about it is I guess these thermostats on the wall, they have a couple different functions, and I didn't really necessarily go into that from my previous podcast. But there's certain, I guess the one thing I wanted to cover was that there's a set point and then there's an offset, and it really you got to think about it. You have to go through it with the temperature controls just so you understand exactly what's happening, because there can be a set point. Where you go up to a thermostat and you say, okay, you know what? I want a set point of 70 degrees. Now, when you do that with kind of a self-contained unit, that 70 degrees, that is a line in the sand. It is going to actuate, it is going to turn on or going to turn off based on 70 degrees. But when you do that typically with a thermostat on a wall, as far as a commercial building goes, that is going to be, you're going to have an offset. You're going to have a deadband offset, because you have the potential usually, and this is when you have like VAV with reheat, which is a very common system. VAV with reheat, sometimes you have constant volume or variable volume temperature or variable volume boxes, and that's kind of like a simpler version of a VAV with reheat system. And so what you have is you have the potential to do both heating and cooling. The logic will dictate exactly what mode it should be in. The user doesn't have to define what mode it has to be in. The logic in the device will actually identify what mode it has to be in by the set point that you give it. So it'll allow, so for example, if you have a set point and you set it to 70 degrees and then it drifts down to 80 or 68, and that might be your heating set point. So your heating set point, if you have a plus or minus 2 degrees, it goes down to 68, and it'll start turning on at 68, and it'll go all the way up until 70, and then it'll shut off. So usually when you're in the heating mode, it'll cycle between 70 degrees, which is a set point that you set, and the offset, which is 68. So turn on at 68, go to 70, turn on, and it could, because primarily the room and that stage, that mode, is typically cooling off. So it's cooling off, you're heating it up a little bit, you're letting it cool off. What you don't want to have happen is you don't want to have, if you set it at 70 and you could do simultaneous heating and cooling, it just wouldn't know what to do. So that's why you have this deadband. So if the room, for example, was set to 70 and all of a sudden it didn't have this cooling effect where it didn't keep getting cool, and then all of a sudden it just started, the sun hit the room and it started heating up. So it would go from 70 to say 72. So if you have 2 degree, you have a 68 to 72. So you go up to 72 and it'll start cooling. It'll turning off the all the heating, the auxiliary heating, all the reheat, it would be off, and it would start opening up the cooling valve, the air valve, and just flooding the room with cooler air. So it would cool it down to 70, and then it would stop. But if you're in that heating, if you're in that constant heat gain mode, it'll heat up again, and then you're cooling it off. It'll heat up and cool it off. So there's this, it kind of cycles between the, when it will turn on and when it'll turn off. And again, that is kind of the range that, you would do, or that you would expect to find in these thermostats. A lot of times it's a little confusing, just based on the fact that sometimes you set the set point, that you want to kind of, you set that 70 degrees, but it offsets 2 degrees automatically. But you don't, as a user, you don't know what those two, what the 68 and 72 are. You don't know that. You just set the 70, and you're like, why is it bouncing between 68 and 70? I wanted 70. So they start cranking it up, and it just kind of, it's something that it's hard to understand sometimes. There are other cases where you're at that thermostat and you're actually just, you're setting the two parameters. You're not picking the one in the middle, but you're saying, okay, you know what? In heating mode, I'm going to be in 68. So whenever the box is in heating mode, that's the only thing that you're going to see on the sensor on the wall. So you're going to modulate that set point. So again, it's kind of different every time you approach that stat, exactly what the control sequence is. And that's why it's good to be able to talk to the temperature controls contractor to be able to figure that out and to identify that. Because they're all just, it's slightly different. And it's one of those things that as many times as I've looked at it, it's like every time I'm like, okay, how is this one working? There are some other other functions that you can get in a thermostat on the wall. And I guess the things that are important typically are going to be occupant control. And what this means is is there is it locked out? There are some areas where if you go into, say, a public area, and you don't want anybody doing anything with it. You just want the sensor. You don't want anything else. You're worried maybe that there's going to be some vandalism, or you want it just to be very kind of bulletproof. So you just have a sensor there and nothing else. No controls, no buttons, no wheels, no displays, anything. It just has a blank plate, and it's a thermistor that's reading the temperature of the space and sending that signal back to the control point, wherever the control point is. There's a thing called the override function. So sometimes you'll see a thermostat that has a button on there. So if the system is shut down, a user can go into a space and say, hey, I want to override the system on, so it'll turn it into, and going from unoccupied to occupied, and it's going to be set up for, 60 minutes, 120 minutes. That's going to be something that's going to be set in the control system and configured in the control system. And then, so it's just a button that toggles on, so they'll be able to push it. There's also thumb wheels. So thumb wheels are kind of a dial. You'll see that a lot of times if, for instance, you don't have a display, and I guess there's kind of two different varieties that I see. You can have one, you can have a thermostat with a display, and with some up and down arrows that you can kind of modulate the set points at. And again, you can still have an override button. You can still have occupant control, or you can lock out control if you don't want to have the occupants do anything with it. And so there's actually and then there's something that you just have just a blank plate with a thumb wheel that either tells a temperature. There's little temperature markings on there, which 68, 70, 72, 80, what have you. Or there's others that are just kind of like, it's going from, warmer to, there might be a sun and there might be a snowflake. So that means hotter or colder. And that'll give a certain, you can change, some of the things like the deadband. A lot of those tend to be more kind of just, I guess, general. They give a little bit more of a programming flexibility than these, precise set points that you might have on, the different, thumb wheels. So I guess, and the point, a little bit of the point, when you're looking at the different sensors and you're specifying them, I would tend to go with just a plain, a blank thermistor, a blank plate, put an override button if you need it, a thumb wheel that with the hotter or the colder, that doesn't give the user a lot of information. A lot of times, if something's not working right, they're going to be, looking at that number. They're going to be fixated on that number. If they can see a number on that dial, they're going to be fixated on it. So you kind of want to remove that if you can. I don't see the benefit of that, because you can trend all the information from the controls, main front end. Why do you need necessarily a specific temperature that's going to, just cause complaints? And this is where I most often see it. You're just kind of cause complaints because, hey, our temperature is X, they'll give a very specific number. And is that going to be right? It might be the wrong number. They might be looking at the set point versus the room, temperature. Yeah, because a lot of times, you'll adjust it and it'll flip back between what the actual reading is and what the set point is. And they might be reading the wrong thing, thinking the wrong information. And once it gets into somebody's head, then it becomes really difficult to be able to, change that. So I guess that was pretty much it. Hopefully that was a little bit clearer than the last time I tried to explain thermostats. If you had any questions, give me a shout out at matt@hvac360.com. Thank you so much for listening. I hope this was helpful. If you know somebody who needs this information or is looking for more basic information, consider passing this episode along. I do appreciate it. Again, if you're not a subscriber at hvac360.com, I would really encourage you to get in, go to that page, register for that. It's a double opt-in form, and basically what that means is when you sign up for it, it's going to ask you, do you really want to sign up for it? And you want to, click yes again, and that's going to get you through the different the processes that we have, and then we'll be able to get you some good information. You'll be able to get in on all the new things that are coming down the pike. If you're listening to this in real time, if you're not listening to this in real time, you may have already missed out, but it'll still be there, and we'll get that information to you. Again, if you want to give me a shout out or give me a review or rating on Apple Podcasts, I greatly appreciate that. It really allows people to find this podcast, and I'll definitely give you a shout out too when you do that. All right, well, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.